For most people, the idea of Earth's magnetic poles feels fixed and permanent. We imagine the North Pole and South Pole as unmoving anchors of the planet, just like the continents themselves. But in reality, Earth's magnetic poles are not stationary at all. They move continuously, slowly drifting across the planet's surface. And in recent decades, that movement has accelerated in a way that has captured the attention of scientists around the world. The question many people are now asking is simple but important. Why are Earth's magnetic poles moving faster than before, and does this change pose any risk to the planet or to modern technology? To answer that, we need to start by clearing up a common misunderstanding. Earth has two different kinds of poles: geographic poles and magnetic poles. The geographic poles are defined by Earth's rotation axis. They are fixed relative to the planet's surface and mark the points where Earth spins. The magnetic poles are completely different. They are defined by Earth's magnetic field, and that field is generated deep inside the planet. Earth's magnetic field originates in the outer core, a vast layer of molten iron and nickel surrounding the solid inner core. As this liquid metal moves due to heat escaping from Earth's interior and the planet's rotation, it creates electric currents. Those currents generate a magnetic field in a process known as the geodynamo. Because the flow of molten metal inside Earth is turbulent and uneven, the magnetic field it produces is also irregular and constantly changing. This is why magnetic poles wander. They respond directly to shifts in the flow of material deep beneath Earth's surface. For most of recorded history, the North Magnetic Pole moved slowly, drifting only a few kilometers per year. Early explorers and navigators accounted for this gradual movement when adjusting compass readings. But in the late 20th century, scientists noticed something unusual. The North Magnetic Pole began to accelerate. In the 1990s, it was moving at about 15 kilometers per year. By the early 2000s, that speed had doubled. In recent years, it has reached speeds of more than 50 kilometers per year, racing from northern Canada towards Siberia. This rate of movement is unprecedented in modern measurement records. The South Magnetic Pole is also moving, though less dramatically. Both poles are responding to changes in Earth's magnetic field, but the rapid motion of the northern pole has drawn the most attention because of its impact on navigation systems. To understand why this is happening, scientists look again to Earth's core. The outer core does not rotate uniformly. Instead, it contains vast streams and swirling flows of molten metal. Some of these flows strengthen the magnetic field, while others weaken or distort it. Over time, these competing influences cause the magnetic field to shift. One leading explanation for the pole's rapid movement involves changes in two large magnetic lobes beneath Canada and Siberia. The balance between these lobes appears to be shifting, effectively pulling the North Magnetic Pole eastward at increasing speed. This process is entirely natural. Earth's magnetic field has always been dynamic. Geological evidence preserved in ancient rocks shows that magnetic poles have wandered extensively over millions of years. What makes the current movement notable is its speed and its relevance to modern technology. Unlike ancient civilizations, modern society relies heavily on precise navigation systems. GPS, satellites, aircraft navigation, maritime systems, smartphones, and even military equipment depend on accurate magnetic field models. When the magnetic poles move quickly, these models must be updated more frequently. This is why scientists maintain the World Magnetic Model, a global representation of Earth's magnetic field used by navigation systems worldwide. In 2019, the pole's rapid movement forced an unscheduled update to this model, something that had never happened before. It is important to emphasize that the movement of the magnetic poles does not mean Earth's magnetic field is failing. The field still exists, and it still provides strong protection against solar radiation. However, it is also true that Earth's magnetic field has been slowly weakening overall for the past 2 centuries. This weakening is not uniform. Some regions weaken faster than others, while some strengthen temporarily. The South Atlantic anomaly is one example of a localized region where the field is significantly weaker. Pole movement and field strength changes are part of the same complex system, but they do not automatically signal an imminent magnetic collapse. This leads to a common fear: magnetic pole reversal. Earth's magnetic field has reversed many times in the past, with the North and South magnetic poles swapping places. These reversals occur on timescales of hundreds of thousands of years and unfold gradually. There is no evidence that a full reversal is about to happen anytime soon. During past reversals, life on Earth survived. Fossil records show no mass extinctions directly linked to magnetic reversals. While the magnetic field weakens during a reversal, it does not disappear entirely. Earth's atmosphere continues to provide strong radiation protection. From a technological perspective, however, rapid pole movement and field variability do matter. Satellites operating in low Earth orbit are exposed to higher radiation in weaker field regions. Power grids can be more vulnerable to geomagnetic storms. Navigation systems must adapt continuously to maintain accuracy. The growing importance of space-based infrastructure means that understanding Earth's magnetic behavior is more critical than ever. This is why space agencies like NASA and ESA operate dedicated satellite missions to monitor the magnetic field in real time. These missions provide data that allow scientists to track changes, update models, and anticipate potential impacts. Looking ahead, scientists expect the magnetic poles to continue moving. The speed may increase, decrease, or change direction depending on how flows in Earth's core evolve. These changes are slow by human standards, but fast by geological ones. The key takeaway is not fear, but awareness. Earth's magnetic field is not a rigid shield. It is a living system shaped by deep planetary processes. The movement of the magnetic poles is a visible reminder that Earth is active beneath the surface, constantly changing in ways we are only beginning to fully understand. As technology becomes more precise and more dependent on space, the invisible forces surrounding our planet matter more than ever. The magnetic poles are moving, not because something is going wrong, but because Earth is doing what it has always done. The challenge for humanity is not to stop this movement, but to understand it, adapt to it, and respect the dynamic planet we live on.